Welcome to Channel Academy. So in today's class, we are talking about surd. So what is surd? Surds are irrational numbers, or you can say surd are roots that cannot be simplified into a whole numbers. Examples of these numbers are, we have root 2, root 3, we have root 5, we have root 7. So these are examples of surd. When you take the root of 2, you discover two things. The decimals are not ending, they are not ending, it keeps going, but at the same time, they are not repeating. Like if you say 1.33333. Now, this one is repeating, so this is not a surd, or it cannot be expressed as an irrational number. But when you talk about irrational numbers which are surd, let's say for example root 2. So root 2 is equal to 1.414213 and so on. You can see that the decimals are not ending, but however they are not repeating. So these are what we call surd. Okay. Now, understanding square roots. When you see a number like this, saying a square of 25, now what this thing is asking is asking for a number that we can multiply twice that will give us 25. So we can have 5 multiplied by 5 is equal to 25. So therefore the square root of 25 is 5. Now, let's take another example. If we have the square root of 4. Now, this can also be written as, oftentimes we don't write the 2 there. So we have 2 multiplied by 2, which is equal 4. So the root of 4 is 2. So that is what square root simply means. So let's take one last example. So if we have the square root of 49, this means that 7 multiplied by 7 is equal 49. That means the square root is 7. Alright, types of surd. So the first type of surd we are going to talk about in this video is the simple surd. The simple surd contains only one surd. So example of this simple surd are, we can have the root of 3, the root of 7, the root of 11. So these are all simple surd. They have just one surd. Okay, the second type of surd we are going to talk about is the mixed surd. So the mixed surd. Now, the mixed surd contains a whole number multiplied by a surd. So it's a whole number multiplied by a surd. So we have a whole number, say we have 3 root 2. So this is a mixed surd. So where this is the whole number and this is the surd. Okay, so this is an example. Also we can have 5 roots 11. This is also a mixed surd. All right, so the third type of surd that we have is the compound surd. The compound surd. Now the compound surd contains operations like addition or subtraction. Examples, so we can have root 2 plus root 3. Now, because of this sign, it is known as a compound surd. So we can also have 3 plus root 2. The sign here tells us that this is a compound surd. We can also have root 2 minus root 11. This is a compound surd. Okay, simplifying a surd. This is the most important part when we are dealing with surd, because this is where question comes out from most. So when we are given a surd to simplify, the first thing we do is to break down the number into factors and take out the perfect square. Okay, so let me write that. When we are asked to simplify surd, we break the numbers into factors and take out the perfect square. So let's take an example to explain this. Now, if we are asked to simplify root 8, what we need to do is to break 8 into two factors such that one of them has a root and the other doesn't have a root, or one of them is a perfect square and the other is not a perfect square. So we have 8. We are going to have two factors. We are going to have 4 multiplied by 2. Now, if we take the root of 4, it is equal to 2. But 2 does not have a root, which means the two factors we will be needing for 8 is going to be root 4 multiplied by 2, because root 4 multiplied by 2 is the same thing as root 8. Now, this can further be broken into the root of 4 multiplied by the root of 2, which is also same thing as root 8. If we take the root of 4, it is 2. So we have 2 multiplied by root 2. So if we multiply this, we are going to have 2 root 2. So this is equal to root 8. So the root of 8, if we simplify it, we are going to have this as our answer. Let's take another example to explain this much more better. Okay, so we're asked to simplify root 12. So if we're asked to simplify 12, so we have to break 12 into two factors. Let's start from, let's say 12. 12 can have 2 multiplied by 6. 6 doesn't have a perfect square, and 2 does not have a perfect square. So let's break it down again. So 12 is equal to 3 multiplied by 4. Now, if you see from this now, 4 has a perfect square. So we are going to use these two factors to solve. This should be equal to the root of 3 multiplied by 4, which is further broken into the root of 3 multiplied by the root of 4. And this will be equal to root 3 multiply. So if we take the root of 4, we are going to have 2. And if we multiply this, we are going to have 2 root 3. This is what we have when we simplify root 12. Laws of surd. So the first law we are going to talk about is the multiplication law. Now, the multiplication law says if we have the root of A multiplied by the root of B, it is equal to the root of A multiplied by the root of B, which can also be expressed as AB. Let's explain this with an example. If we have root 3 multiplied by the root of 2, it will be equal to the root of 3 multiplied by 2, which is equal to root 6. Let's take another example to explain this much more better. If you have the root of 5 multiplied by the root of 3, this will be equal to 5 multiplied by 3, which is equal to root 15. Alright, so this is the multiplication rule. The division law. The division law says if we have A, the root of A over the root of B, it is equal to root of A over B. So let's explain this with an example. If we are given the root of 18 divided by the root of 3, this will be equal to the root of 18 over 3. 18 divided by 3 is going to be 6. So we have the root 6 as our answer. Alright. So let's take one more example to explain this much better. If we are given another example, so we have root 35 divided by root 5. This is going to be equal to root of 35 over 5, which is equal to the roots. So 35 divided by 5 is 7, so it will be root 7. This is our answer. Some key things to note in sort. Now you must take note of the following things I'm about to show you. So the first thing is multiplication of same sort. So multiplication of same sort. If we have roots a multiplied by roots a, the answer is a. So let me explain that with an example. If we have the root of 2 multiplied by root 2, now we are definitely going to have 2 multiplied by 2, which is going to give us root 4, and the root of 4 is 2. That's why the multiplication of same sort will give you that number. Let's just take one more example. Suppose we have root 3 multiplied by root 3. We are going to have root 3 multiplied by 3, which is equal to root 9, and the root of 9 is 3. So whenever you multiply same sort, to give you the number. All right. So the second thing you need to take note of is addition of same sort. Now you must take note that addition in sort can only happen to like terms or like sort. So if we have root a plus root a, it is equal to, so this is one root a, another one root a, so it becomes 2 root a. If we have root a plus 2 root a, now take note, there's an invisible coefficient here, which is 1. That's why this one is 1. So we add the coefficient together and then we keep the sort. That's how we have this 2. But this point now, there's an invisible 1 coefficient there. So when we add it to the 2, it will then give us 3 root a. How about if we have root a plus root b? Now this one cannot add. That's why I said it can only work for like terms. This is like saying x plus y. They are not the same thing. Same thing applies for subtraction. So if you have, let me use another example. So if you have 2 roots a minus roots a, so the coefficient will subtract each other. So we have root a. And take note, we cannot have root 2 root a minus root b. It will remain the same thing. It won't change. All right. Let's take some example. So this is an example before us. We are asked to simplify this sort. So we are asked to simplify this sort. So the first thing we need to do is to break each of the sort into 2 factors. So for 8, we have 9 multiplied by 2, which is 18. For 72, we have 36 multiplied by 2, which is 72. And for 50, we have 25 multiplied by 2. All right. So then we can say it's equal to 5 brackets 9 multiplied by 2 minus 3 brackets the root of 36 multiplied by 2 bracket close plus 4 bracket the root of 25 multiplied by 2. And this can be further broken into 5 the root of 9 multiplied by the root of 2 minus 3 brackets the root of 36 multiplied by the root of 2 bracket close plus 4 bracket the root of 25 multiplied by the root of 2 bracket close. Now becomes 5, open bracket. Root 9 is equal to 3, and 3 multiplied by root 2, it becomes 3 root 2 minus 3. Root 36 is equal to 6, and 6 multiplied by 2 is 6 root 2 plus 4. The root 25 is equal to 5, and 5 multiplied by 2 is equal to 5 root 2. So from this point, you can open the bracket. So you multiply the coefficient. That will give you 15 root 2. So this will be 15 root 2 minus. So 3 multiplied by 6 root 2. We are going to have 18 root 2. 18 root 2 plus 4 multiplied by 5 root 2. We are going to have 20 root 2. So we have 20 root 2. Now we can do our direct subtraction and addition. So 15 root 2 minus 18 root 2, we are going to have minus 3 root 2 plus 20 root 2. This will be equal to 17 root 2. This is our answer. All right, so let's take another example. All right, so we're asked to simplify this question. So this question is a straightforward multiplication. So in this case, for you to be able to multiply this, so let's bring it down. We have 2 root 3 in bracket, so, and the other bracket 4 root 2. What we need to do is, now, this 2 is the coefficient. This is the coefficient, and 4 also is the coefficient. So we are going to multiply the coefficient and also multiply the root. So the first thing we'll do is, the coefficient is 2 and 4. So say 2 multiplied by 4, put in bracket, and then open the bracket, becomes 3 multiplied by 2. So this is what we have. So when you multiply this, it is now equal to 2 multiplied by 4 is 8, and 3 multiplied by 2 is root 6. So this is our answer. So whenever you have two mixed surd multiplying, you multiply the coefficient and then multiply the surd. That way you have your answer. Rationalization of a surd. Now, rationalization means removing a surd from the denominator of a fraction. So now, when a surd appears as a denominator in a fraction, we have to take it out. So that process is called rationalization. All right. Suppose we have, say, if we have root a over root b, root a is the numerator, and then the root b is the denominator. So we do not want a surd to be the denominator. All right. Types of rationalization. All right. So the first type of rationalization we're going to talk about is single surd in denominator. So what this means is that if we have a single surd in the denominator, for example, if we have a over root b, so this is an example of a single surd being the denominator. This is just a single surd, and it is the denominator. All right, so let's see how we rationalize a single surd. All right, so if we have a over root b, what we need to do when we want to rationalize it, we multiply the numerator, which is a, by the denominator, which is root b, and we do the same thing for the denominator. Let's take an example to explain this. All right, we are asked to rationalize 1 over root 2. So what we need to do is to multiply the numerator by root 2 and also multiply the denominator by root 2. Okay, so we have 1 over root 2. So the denominator is the surd, and we need to multiply the numerator by the surd 2, and also we multiply by root 2. And this will give us root 2 multiplied by root 2. Now, if you've been following the video, you know that root 2 multiplied root 2 is going to be 2. So we have root 2 over 2. This is what we have. Let's take more example to explain this much better. All right, in this example, we are asked to rationalize 2 over root 3. So what we need to do is to multiply both the numerator and the denominator by the surd. Same thing, just 2 over root 3 multiplied by root 3 root 3. Now, this is then equal to 2 multiplied by root 3 and root 3 multiplied by root 3, which is equal to 2 root 3 over 3. This is our answer. Let's take one more example. All right. So in this case, we have a coefficient and a surd as the denominator. So what we need to do, you can solve this in two ways. You can multiply the numerator by the coefficient and the surd, and also do the same thing for the denominator. But the fastest way is just to use only the surd, and this is the surd, only 2. So let's use the 2 method and see. So we have 2 root 5 over 3 root 2. And if you multiply by 3 root 2 over 3 root 2. So you multiply the coefficient, 2 multiply by 3, and then we multiply the surd, 5 multiplied by 2, all over 3 multiplied by 3 brackets 2 multiplied by 2. And now this is going to give us 2 multiplied by 3 is 6, 5 multiplied by 2 is 10, so 10, all over 3 multiplied by 3, we're going to have 9. 2 multiplied by 2 is going to be 4, root 4 is 2, so we have 2. This is equal to 6, 10 over 18. Now we can simplify this by dividing the numerator by 6 and the denominator by 6. So if we divide 6 by 6, we have 1. If we divide 18 by 6, we have 3. So our final answer will be roots 10 over 3. And that's if we multiply with the coefficient and the roots. So let's try if we multiply with only the roots. So let's try to solve this question again, but this time we are going to multiply the numerator and the denominator with only the surd, which is root 2. Okay, so we have 2 root 5 over 3 root 2 multiplied by root 2 root 2. Now if you multiply that, you are going to have 2 root 10. That's the surd multiplying the surd is going to be 10, all over, and this is going to be 3 multiplied by 2, because when the surd multiplies the surd is going to be 4, and the root of 4 is 2. And then we are going to have 2 root 10 all over 6. So if we divide 2 by 2, we are going to have 1. If we divide 6 by 2, we have 3. And then you see that we have the same answer, root 10 over 3. And you see this method is faster and easier. So if you have a question like this, you just multiply by only the surd. Okay. All right. So the second type of rationalization is when we have a binomial or a compound surd as the denominator. Now, if you've been following the video, you already know that a binomial, a compound surd, is the surd that is combined by an operation, addition or subtraction. Okay, so let's see how to do that. Now, when we are rationalizing a binomial surd, we used a conjugate. Now, what's a conjugate? A conjugate is like an opposite. So let's say we have A plus root B as a surd. Now the conjugate is going to be A minus root A. Now what changes is the sign. The sign changed. Okay. If we also have A minus, let's say, root B, it becomes A plus root B. This is what we mean by conjugate. So when we want to rationalize a compound or binomial surd, we multiply the denominator and the numerator by the conjugate. So let's take an example to explain this much better. All right, for us to rationalize this surd, we must take note of its conjugate. So the conjugate of the denominator will be 2 minus root 3. So this is the conjugate. This is what we are going to use to multiply the numerator and the denominator. All right, so let's write that down. 1 over 2 plus root 3. I will multiply the numerator by 2 minus root 3. And then do the same thing for denominator. So the denominator 2 minus root 3. So we're going to have, if you multiply the up, you're going to have 2 minus root 3 all over. Now, there's something you must take note of at this point. Whenever a surd is multiplying its conjugate, it's going to have, let's say we have A plus root B, multiply its conjugate A minus root B is going to give us A square minus root B square. So this is what we are going to have, and which is further broken into A square minus B, since the square is going to take out the root. All right, so having this, let's quickly do that. So we have 2 raised to the power of 2 minus 3, and then if we do this, you're going to have 2 minus root 3 all over 4 minus 3, and then this is going to give us 2 minus root 3, since 4 minus 3 is going to be 1. So this is going to be our answer. All right, so let's take more example. All right, so we're asked to rationalize this. So for us to rationalize this, we must also take note, don't forget that the conjugate of this is 1 minus root 5. Okay, so that's what we're going to use to multiply the bottom and the top. So we have 4 over 1 plus root 5 multiplied by 1 minus root 5, 1 minus root 5. Now, if you multiply that, you're going to have 4 bracket 1 minus root 5 all in bracket over. So we are going to have 1 square minus 5. And this is going to be equal to 4 open bracket 1 minus root 5 bracket close all over. The square of 1 is 1. 1 minus 5 is going to give us minus 4. All right, so we can cancel out 4 into 4, 1, 4 into minus 4, minus 1, and therefore we're going to have, our answer is going to be minus 1 minus root 5, and this can further be given to, so if you open the bracket, you're going to have minus 1 plus root 5, which we can then arrange to be root 5 minus 1. This is our answer. Thank you for watching to the end. Please do not forget to hit the subscribe button and watch out for more videos like this. Bye for now.